Kevin,
Yes.
we are talking about hydrates. And in this course, and in most chemistry courses, hydrates appear just about the time that people are calculating molar masses of compounds. And then they get shown this hydrate, and it gets in the way of them. They're not quite sure how to handle it. So what I want to do is I want to start off first. I want to calculate the molar mass of of one compound. I'll do the writing. You do the putting into your calculator part. Okay.
Sounds good.
Cool. All righty. So we're going to start off with copper sulfate. And I guess to be fair, I happen to know this polyatomic ion is sulfate 2-. So that tells me that my copper must be 2+. So it's actually probably copper 2 sulfate. Just reminding ourselves that this 2 tells us what the charge is on the copper, but it's not really important for this particular thing, this particular calculation. What we're going to do is we're going to calculate the molar mass of copper sulfate. So we are going to have a copper atom, a sulfur atom, and 4 oxygen atoms. Okay?
So far, so good.
Okay, so I've got 1 times 63.546 grams per mole for copper. So here's copper, element number 29. It has a molar mass of 63.546.
Yep.
Okay? And as long as we're here, let's go get sulfur. Sulfur, element number 16, is 32.064. And we're going to need oxygen, which is right above it, at 15.99. So we've got 1 sulfur. So we've got 1 times 32.064 grams per mole for sulfur. And we've got 4 oxygens times 15.999 grams per mole for oxygen. I'll do the first 2, you do the last one.
Yep.
I can multiply by 1 in my head.
And then
should be just a little less than 64, right? So it's
63.996.
996. I probably should have been able to estimate that, because each one of these is 0.001 grams less than 16, and so I got 4 of them. So I should be 4 less than the rounded number of 64. So this is where I need you.
159.606.
606. And I'm pretty happy with that, because I see 6 plus 4 is 10 plus 6 is 16, ends up with a 6 down here at the end. There's a good chance that we've not made a mistake. So that would tell us that the molar mass of copper 2 sulfate is 159.606 grams per mole. Okay, so this is a calculation students are going to do over and over and over again until it's totally trivial doing it. However, you might see copper 2 sulfate, but you might run into something that looks a lot, it seems like it's the exact same thing, and it'll say something like copper 2 sulfate pentahydrate. And all that really means is that we've got a copper sulfate molecule, copper sulfate, and it has attached to it some water molecules. And in this case, the number is 5 of them. So you might see the formula for copper 2 sulfate pentahydrate written as CuSO4.5H2O. And all that really means is that when this compound precipitated or dried out, that there were 5 water molecules that are probably attached right in here next to this carbon, and so that they surround the carbon in
the copper.
Sorry, yeah, copper. Sorry, the copper in the solid lattice. So we've got 5 water molecules, 5 hydrates attached to the copper sulfate. So you might need to do a calculation. You might need to work out something associated with the molar mass of this. And so we're going to do it the exact same way. I've got 1 times copper. Look at that. I got it right this time. I've got 1 times sulfur. I've got 4 times oxygen. I could get cocky, but I'm not going to, and say I've got 4 oxygens here and 5 over here, and change this number to a 9. But life is much simpler for you and I if we don't do it that way. So now I've got just like we had above. Now I'm going to worry about my 5 water molecules, which is 10 times hydrogen and 5 times oxygen. I'll do the first 3. 1 times 63.546 grams per mole copper. 1 times 32.064 grams per mole sulfur equals 4 times 15.999 grams per mole oxygen equals 10 times 1.0079 grams per mole hydrogen equals 5 times the oxygen again, 15.999 grams per mole of oxygen. I can do the first couple, 63.546, 32.064, 63.996, and this one must be 10 point something. 10 point, what do we get?
10.079.
So, oh, of course it is. Yeah, of course it is, right? I should have been able to do that one too. All right. So redeeming ourselves on the 5 times 16. What is it? What is this? 5 times 15.999?
79.995.
0.995. And if I add all of those up,
249.68. And I believe the last digit says 0.
okay. So 10, 19, and 11 gives me 20, 0. Yeah, I'm good for that. So 249.680 grams per mole for CuSO4.5H2O. And we feel pretty good about that?
Yeah, so you just needed to add the molar mass of 5 water molecules.
Yeah, yeah. Oh, this would be an excellent opportunity to do it a different way, wouldn't it? Because we could have figured out what the mass of 1 water molecule is, 18.02, multiply that by 5, and I'm guessing that adds up to 89, right? Because they had the 10 and the 79, right? So there are multiple ways of doing this. The most important thing is to recognize when you see pentahydrate, it means 5 water molecules attached to the copper sulfate or whatever the hydrates are attached to. What do you make of that?
Makes sense. It takes a scary long compound name and makes it a little bit more digestible.
Yeah, I mean, we managed with 2 compound names to probably write down close to 60 or 70 digits and fill up a page of notes, and without too much work, right? I mean, we just had two compounds. We wanted to find out their molar mass, and we were able to occupy ourselves nicely for 4 or 5 minutes. Okay, let's look at 2 others.
All right.
Sodium carbonate comes with at least 2 different types of hydrates. One of them has 10 water molecules, and so we call this one sodium carbonate decahydrate. Deca, 10, just like decade, right? If I wanted to calculate the molar mass of this one, it'd be 2 times sodium, it'd be 1 times carbon, and 3 times oxygen, and then 20 times hydrogen, and 10 times oxygen. Carry on, carry on, carry on, carry on, carry on. And we'd end up with some number down here. Sodium carbonate doesn't just form the decahydrate, it also forms a monohydrate. So it forms a compound, sodium carbonate monohydrate. And sodium carbonate, Na2CO3. Mono means 1 hydrate, dot H2O. Often I don't know if I've ever seen one that has a 1 in here. I think if there's nothing there, it means 1. And so I don't think we have to write the 1, but we call this sodium carbonate monohydrate. And we find the molar mass of this the exact same way. 2 times sodium, 1 times carbon, 3 times oxygen, 2 times hydrogen, and 1 times oxygen. And we just keep on going. And eventually we get down here and we have a little number that we felt so good about that we circled it because it made us feel like we actually accomplished something.
We use them mostly in labs. You'll probably be calculating these in like the labs where you actually deal with chemicals and stuff. But we don't tend to use them often in exam questions or practice homework questions.
Yeah. Oh, now I'm inspired for a homework question. I mean, I think it's fair game, right? I mean, but yeah, it's certainly a very classic lab experiment is to take some hydrate that we don't know what it is, and you weigh a certain amount of it out, and then you heat it up like crazy and derive all the water off, and then you have basically only this compound left, and you figure out what your difference in your mass is, and then you can figure out, oh, I must have driven off this much water, 10 waters or 6 waters or 5 waters, and it tells you what the formula is. So it's pretty slick lab in the sense that you go from a compound that you don't know what its formula is. 3 hours later, you know what its formula is. Pretty slick. Yeah. So that's hydrates.
Yep, that's hydrates.
I bet you're glad you were here.
All right, thank you, Dr. Hunter.
All right, thanks, Kevin. Okay, talk to you again soon.
Yep, talk to you soon.